Okay, on the left-hand side, we can see the client code for the PLC in structured text. There's a Boolean command to run the client. Every 255 times we reset the ID number of the pet, and we set the pet to 4 years old, 5 legs, and the current loop number for the ID. And then we check to see if the socket exists, if the socket's got data ready to receive. If not, we open the socket, we connect the socket and bind it. If it is connected, then we send the TCP/IP data to it. So the data is defined in a structure here, unsigned integers, so 2 bytes per integer. The C++ real-time portion of the code is imported from Beckhoff's samples on their website for the TF6311 module. So there's no change made to any of these, it's just compiled straight from the example. And then the real-time Ethernet adapter is assigned to the object from the compiled C++ code, and the 3 things all tie together. So the scan time of this task is 50 milliseconds, so every 50 milliseconds, plus or minus the time it takes to empty the buffer, the data is sent to the client. So on the right-hand side here, you can see the source code on the server end, so this would be a microcontroller or some other device. So we've got a structure defined in C, integers, they're set to assign 16-bit integers here, 2 bytes. And then there's a streaming socket that's opened. Every time a buffer length at the appropriate length is read, the bytes are then cast to the structure, and then the structure is read and printed out to the console for debugging. And the buffer is emptied, and the loop continues. So if we exit this and we run the pet server, you can see the PLC is already running. So as soon as the server became available, the socket was connected. Pet age is 4, legs is 5, and then the client, the ID is cycling between 1 and 253, which you probably struggle to see in the video. So that's running away quite nicely. We can cancel that. So that's how you implement raw TCP/IP sockets in the Beckhoff PLC.